Hi there, I'm really hoping by the end of this you're going to be much more confident about using equations in your GCSE Physics. Whether you study OCR Gateway, this is the equation sheet from that specification, or any other specification of GCSE Sciences, you're going to see an equation sheet at the front of the physics papers or the physics sections. This one, as I said, is from the OCR Gateway, and the first four are from the P1 section, and the next two are from the P2 section. And that makes up all the equations you're going to need to apply in core. There's not that much calculation in core, but you do need to be confident to use it when it's asked. In addition, however, and this is the case in all specifications, there are loads of calculations to do. All of those ones are the mechanics section of additional, which is P3 in OCR Gateway. Now the next little one there, that's Ohm's law, it's a very important one, is a P4 equation. So you might have to apply that in P4. You might also have to apply these two over here. The power is voltage times current one. And then if you're doing triple, then you've got a bit more mechanics to do, the tricky stuff with the suvat here and conservation of momentum there. And you've got all the stuff applying to waves and transformers down here in P5 and P6. I'm really hoping by the end of this video you can be confident in using and applying those equations and perhaps being able to rearrange them. I'm going to start here by using an equation you come across pretty early on in your additional science. It's the equation force equals mass times acceleration. It's Newton's second law. And I'm going to use, throughout this, I'm going to use algebra. And I want you to get used to using the algebra symbols for these because it's just quicker. You don't have to write out every single time the words. We just get used to using capital F for force, little m for mass, little a for acceleration. It makes our life easier. Algebra is there to make your life easier, not harder. Well, this type of question will be pretty easy if they give you a mass in kilograms and acceleration in meters per second squared, and you can work out the force in newtons. That's fine. That's going to be one of the easier questions, and they might well ask you to do that. The equation's ready. But what if they give you a force and acceleration and ask you to work out a mass? Well, that's a little bit harder, isn't it? Because you need to rearrange that equation into mass equals. Well, what if they give you a force and a mass and ask you to work out an acceleration? Well, you need to work out an equation for acceleration then. So the way I think that you probably have come across rearranging this is to use the triangle method. So you draw yourself a little triangle and you know that if you see two numbers at the bottom, it means they're going to be multiplied together. And if you see one number over one algebra over the other, it means the top one is going to be divided by the bottom one. And the same for this side. So all you have to know how to do then is to get these quantities into the triangle. Well, how do you do that? Well, let's imagine we were trying to work out what force was equal to. So you use your thumb, or I'm going to use a target, to think, well, what if I was targeting the F? What if I was after the force? Well, where would I see the other two? Well, they're both being multiplied together, so I would see them on the bottom line. So I can fill them in straight away. Mass times acceleration equals force. That means I have to put the force at the top. Now I'm ready to use the same idea to actually work out what the equation for mass is, and then the equation for acceleration. So covering up the m, I've got F divided by A, force over acceleration. And if I want an equation for acceleration, I do a similar thing, covering up the A, and I see F over m, F divided by m, force divided by mass. And I hope that makes sense. Now most equations are just this form. You've just got three quantities which are related to each other. So I'm going to show you the general idea then. If I have quantity A equals quantity B times quantity C, then I can use F formula triangle to work out an equation for B equals or an equation for C equals. Okay, let's have a crack at that. So imagine I was covering up the A with my target or with your thumb. I would see B and C at the bottom, therefore I can fill them in, and A has to be at the top. So when I want B equals, cover up B, A divided by C, when I want C equals, I just need to cover up C, and I've got A divided by B. That's a very simple, exactly the same for all different sets of quantities that are related in an equation like that. Now, if you're confident with algebra, you may want to start getting used to the idea of inverse operations. I'm going to show you the same thing if I have the equation A equals B times C. To rearrange it to B equals, I just need to move the C across. So this is called working with inverse operations. And if you want to use the triangle method, that's fine. But I think this is quicker. So if I've got times C, the inverse of that would be divide by C. So to move it across to the other side, I divide both sides by C. So then I end up with A over C equals B, which I hope you can see is the same equation as this first one we rearranged using the triangle. The same would be the case if we want to move the B, so that we get C equals times by B, the inverse of that is divide by B. So we've got a new equation now where A over B equals C. And that's the same thing. Now I would prefer you work like this, the second method, if you follow that and you're comfortable with that, because it will speed things up in the future, and there are some equations that aren't quite as simple as this and you can't really use the triangle in the same way. So I've just got some examples here of some other equations that you're going to need to apply. This one, work done is force times distance, and I want you to try and rearrange them to force equals and distance equals. And this one, power equals work done divided by time. I want you to try and rearrange them into work done equals and time equals. Here, momentum is little p equals mass times velocity. You rearrange this into mass equals and velocity equals. And here, Ohm's law again, resistance is potential difference divided by current. Rearrange it into potential difference equals and current equals. Have a go. You can either use the triangle method or the inverse operations, depends what you want to use. Pause the video, have a little go now, and then I'm just going to quickly show you what you should have got. Okay, so let's go. I'll just do the triangle method for simplicity's sake. If I was covering up W, I'd see W at the top, so that's my triangle there. Force equals work done divided by D. Distance equals work done divided by force. This one then, if I was covering up P, then I'd see W over T. So P's got to be, power's got to be on the left. So work done equals power times time. Time equals work done divided by power. Okay, here momentum one, I'm going to draw a triangle again. If I was covering up momentum, that would be at the top. M and V would be next to each other at the bottom. I'll just move my target. If I was covering up M, then I would see P over V, momentum over velocity. If I was covering up V, I would see P over M. So I can calculate those two. Lastly, Ohm's law. V is always at the top. If I was covering up R, then I would see V and I here and here. So V would equal R times I, and I would equal V over R. I hope you found that pretty simple. Let's move on to just the one or two that you can't really use this method, and I'll show you how to rearrange those. Here's one. We've still got three quantities, but they're not really related to each other in that simple manner. It's kinetic energy equals a half times mass times velocity squared. So it's a different relationship. I'm just going to rewrite this because I don't like the fact that in this one they use KE. I'd rather just represent that by E for energy, and remember it's kinetic. And the half times mass times velocity squared. You still, if you get mass and velocity, that's a nice simple one. You just type in the calculator 0.5 times whatever the mass is in kilograms times the velocity in meters per second and square that velocity. Don't square the whole answer, be careful of that. If you've got a scientific calculator, that'll be fine because it'll do the indices before it does the multiplication. So let's say we want to rearrange it for mass or velocity. Let's have a little crack at that. Mass is not too difficult, so we'd use the inverse of operations. Just move the half first. If you times by a half, then the opposite of that, the inverse of that, is divide by a half. And divide by a half is the same as times 2. So what you have on your next line is 2e equals mv squared. So if you now you've just got three things that are related to each other, you can just rearrange it. Times the v squared becomes divide by v squared on the other side. So 2e, 2 kinetic energy, divided by velocity squared equals mass, and you can work out the mass like that. Okay, not too difficult. Let's do it again for rearranging for velocity. If we want velocity equals, how do we do that? So E equals a half mv squared. Alright, trickier one now because we've got that v squared. First step is the same, times by a half is the same as the opposite to times 2. So I've got 2e equals mv squared. Now I need to move the mass next, so I want to leave v on its own. Times by mass is the same as the opposite to divide by mass. So 2e over mass equals v squared. Now I just need to do the inverse of squared, and the inverse of squared is the root of. So my next line is the root of 2e over m equals v. Now you must remember that you need to do in the calculator root, brackets, all of that, and then hit the equals, or at least calculate 2 over 2e divided by m and then root that answer to get v. You have to do it in the correct order, otherwise you're going to get a funny answer there. So actually it's not too difficult, and what I would suggest, if you really struggle with this and you're doing the higher tier, then you might be expected to do these. So I would memorize these two equations, these two forms, and remember that they can be used to solve for one of those, m or v, if you get given the energy and one other one of those. Okay, I hope that helped. One more to come. So this one is one of the more complicated relationships in additional science physics. You should recognize this half mv squared is what we just talked about in the last slide. That is the kinetic energy. So what this equation is relating kinetic energy to mass times gravitational acceleration times height, which is the equation for gravitational potential energy. This is the idea when we're on a roller coaster, that we've got some gravitational potential here, GPE, and it's all converted to kinetic energy when we're at the bottom there. Or the same could be said if we're just a ball or an object that's being dropped a certain height. We have a certain amount of GPE and a certain amount of kinetic energy, and you're most usually going to be asked to work out the velocity of something when it hits the ground or at the bottom of a drop. So I'm just going to show you how to rearrange this for velocity. Now this question will also be tricky because sometimes they will deliberately not give you one of the quantities that you've got. They will not tell you the mass. So the first step is actually quite a simple step. mgh equals half mv squared. Because we're talking about the same mass at the top of the slope and the bottom, or at the top of the drop and the bottom of the drop, we can actually just cancel out the masses straight away. So what we say is because m is on both sides of the equations, m cancels. It's like dividing both sides by m. So we've got gh equals a half v squared. Now this looks something similar to what we were dealing with on the previous part with kinetic energy. Let's move the half. Divide by a half becomes times 2 when it's on the opposite side. So we've got 2gh equals v squared, and I hope you remember how to do the inverse of square. The inverse of square is the square root. So we've got root 2gh equals v, and that will allow us to calculate the velocity at the bottom of the drop or the bottom of the slope. That is assuming, of course, that there is no air resistance. Whenever you see that in a question, ignore air resistance as a clue that that's the relationship you're going to need to be using. Again, I would suggest, boys and girls, you memorise that form there so that you don't have to bother doing all of this rearranging in the exam. I really hope that was helpful. I hope you now see it's not as difficult as you were maybe thinking working with these equations. It really is a matter of practice, boys and girls, and I know you can all do it. Don't forget to like this video if you did, and leave some positive comments below. Or if you think to yourself, well, hang on, there's something else I want to ask, then feel free to do that. My channel is Gorilla Physics, so check out some more videos on that for more help with your physics and more detail about this type of thing.